Hello friends, in this video, and this is the second video of my integration by parts, where I'm going to show you the shortcut trick. What happens, this is a type 2. What happens if we have a question wherein we have to use integration by parts technique? But the thing is, we have two functions. If we go on differentiate and integrate, it won't stop. I mean, it will continue. So how to tackle and how to do about that, those particular questions within no time basically. So how are we going to do? Select the differentiation one and the integration one that you are going to do. I'm taking e raised to x. So if I differentiate it, I'm doing this with the technique DI, differentiate and integrate, remember. Now I'm writing this differentiation. This is like tabular form, D and I am writing it. Integration means first function, whatever we took, just keep it intact. If I integrate it, what I'm going to get? Sin x. And further integrating, what it will give me? Cos x. Correct? So stop it at there. The moment you get the same, because if we go on doing it, we'll get the repetition. I mean, it will repeat. Similarly, this one. So where should we stop? That an earlier technique, what I told you, okay, when we differentiate, after getting a constant, we have to stop. But here in this one, it is infinite. So we just need to stop it at the integral where the function is giving you the same one. So I've stopped it over here. Apply our technique of signs, plus, minus, and minus. And then here what you have to do is just times it like this. Because if you do with this one, ultimately you're going to get the same integral what we are doing. So we are integrating basically. So I'm writing it as I e power x times this one, positive only. Similarly, this also will give me a positive. Okay, e raised to x cos x. And this, if you remember, I'm multiplying these two together. So plus into minus minus. And what is e raised to cos x? Nothing but for which I'm finding the integral. So I'm taking it as I. Bringing it to the other side, it gives me 2i e raised to x common sin x plus cos x. The final answer is nothing but e raised to x sin x plus cos x whole divided by 2. Isn't it very simple, students? So that is how you're going to do. This is the type 2 question. Okay, let's just move on to our type 3 question, which I'm going to do with the log. How are you going to do when you have the questions which is based upon the log powers? So let us just take type 3. We are learning which involves a function with logarithmic, whether it is x square, or you can take with the lower power and work it out and check what you're going to get. So let's just work it out with this x square one, then we'll move on to x3. So I'm taking log now, differentiating it 1 by x. Now if you see, it keeps on going it like that, decreasing, but still it will give you further differentiation. If you go, you will have a result. It won't stop it and give you 0. Now take up this one, x cube, right? Sorry, we are doing for x square, so write x square. If I integrate it, remember this is differentiation, this is I'm doing the DI method, differentiation and integration technique to work it out and find the result for integration by parts questions. So write the question that we are doing x square as it is. In the next step, you will get increasing in the numerator as well as in the denominator, 2 plus 1, 2 plus 1. So now, even if I go on integrating this particular function, I'm going to get, okay, the values. It won't stop it also. So then where should I stop it in this sort of thing? So here the same thing. Here you have 1 by x and x cube. If you multiply these two, you check, you will get x square. So it means you have to stop. So then how to proceed? Take a plus, minus. Okay, we are integrating it. So how you should go about it? Multiply this one first. So x cube by 3 log x. I'm working out with this solution. Then minus integral 1 by x times x square by 3. Upon cancellation, what it will give me? This is x cube. Upon cancellation, it will give me x square. So 1 by 3 can be pulled out. It is x square into dx. So upon further integrating it, I'll get x cube by 3 plus c. It means my solution is now x cube by 9 plus c. Isn't it very simple? Let's just work it out by increasing a power in x, and let's just check how to do it. Come on, differentiate and integrate for this question. Now I'm working out. So here I have taken log x, Eilert technique, log I have taken as the first function. So the first function we have to differentiate. By writing first time same, second time onwards we are differentiating. Log x 1 by x, again it will give me minus 1 by x square, it goes on. Now integrating x cube means first time I will write as it is, second time it will give me x raised to 4 upon 4. As I told you, I have 1 by x and here I have x raised to 4. Even if I proceed, I will get the function in the increasing power. So what I have to do, I have to stop it at here. The reason being is, if I times these two, I'll get x cube. It means it's giving me the original function, so I should stop. Now applying the signs, plus minus plus, anyway this I'm not going to use it. I need to multiply these two and integrate. First I will multiply this one diagonally. Okay, so what I'm going to get, see here now, this anyway not required. So x raised to 4 upon 4 log x. Okay, x raised to 4 upon 4 log x. Then what I told you, minus integral 1 by 4 into x cube, because x raised to 4 and x gets cancelled. So you get x cube. If you bring that 1 by 4 outside, you will get x raised to 4 by 4, which means the final answer is x raised to 4 by 4 log x minus x raised to 4 by 16 plus c. This is the technique that we have used it. And if you want to check your result by doing with the original way, the usual way method that we do with the formula, you check that your answer would be same. It would be same. I hope you like the shortcut. Please like, share, and subscribe and spread it to others. Thank you.